Hello, my name is Melanie Muñoz Osorio, and today I will be talking about the physical geography of El Morro in Puerto Rico. I'll start by speaking about the 5 themes of geographic science. Those are going to include place, location, region, movement, and human-Earth relationship. Let's start with place. Place is El Morro in Old San Juan, Puerto Rico. It is a strategically located coastal fortress on the northwestern tip of the isleta of Old San Juan. It is a small island connected to the main island of Puerto Rico. I included some pictures here so you can kind of visualize it. For location, the address is in Castillo, San Felipe del Morro, 501 Calle Norzagaray, San Juan, Puerto Rico. Here are the coordinates, and I also included a map. I also added a kind of an arrow so you can kind of see where exactly it is. I know it's kind of small, but you can kind of see right there the small isleta that is connected to Puerto Rico. Now let's go into region. I did choose a couple different topics for this. For design and structure, it is a fortress style, Spanish colonial military architecture. The material is composed of stone, brick, and mortar to create thick masonry walls. It is about 43 meters above sea level, and it is a six level fort with sloped stone walls that are angled to deflect cannonballs, sentry boxes, garitas, which I did include a picture right here. Those are called garitas. And they are just iconic observation areas around all of the sections of the fortress. It was used for the Spaniards to kind of look through there and see if there were any enemies and they were still protected. And those are garitas. There also are ramparts, cannons, and turrets, courtyards, powder rooms, and barracks. The shape is irregular because it's contoured by like the rocky coastline that is intended for maximum coverage. It is located on a rocky promontory that juts into the Atlantic Ocean. It's surrounded by grassy areas and cliffs leading to the sea on every single side. So it is exposed to ocean winds, spray, tropical elements. It affords ocean and San Juan Bay views throughout, as well as panoramic views from the lookout and courtyard. So since it was a strategical Spanish colonial military architecture base, they needed to be able to see from every single angle if there were enemies coming. So all you can see is just beautiful ocean and panoramic views throughout. It is in North America and the Caribbean. It's in Puerto Rico, Old San Juan to be specific. For its surroundings, for the north side, it's south of the Atlantic Ocean. It has the entrance to the San Juan Bay, which was a fortress that we're protecting. And for the east and south, it's a historic walled city of Old San Juan with cobblestone streets and Spanish colonial architecture. So if you visit Puerto Rico, which I totally recommend you should, you will see all of the original architecture where all of the Spaniards used to live in, and we still very much keep that upkeep with the architecture, and people do still live in those. And I'm pretty sure now there's some Airbnbs in there. But be sure to visit. It's absolutely beautiful. All right, and then for the movement, for the tectonic plate location, El Morro is situated on the Caribbean plate, close to the boundary with the North American plate. I kind of added a picture over there on the side so you can kind of visualize it. The Puerto Rico is located in a complex transform fault zone where the two tectonic plates are sliding past each other in a predominantly horizontal direction. It is gradually and like very, very gradually moving east. We're on the plate at around 2 centimeters per year relative to the North American plate. And it is very gradual over time, but it is affecting the entire island of Puerto Rico, including El Morro. It is seismically active, which means that the land mass is susceptible to earthquakes and minor uplift or subsidence of like sinking and rising land. We have had a couple of earthquakes not too long ago. Morro has not moved for the most part. This tectonic stress is exerted in the crust, and several micro movements can occur. And then for the geological formation, the rocks below our Morro are a part of the upper Cretaceous volcanic and sedimentary rock formations. I believe I said that right. That formed millions of years ago. They do provide a solid and uplifted foundation, and that was why the Spanish decided to kind of build a fortress on that site. Right, and now for the human-Earth relationship. So, as seen by the Spanish settlers, the elevated rocky cliffs at the edge of the islet provided a strategic and stable geologic base to build on. The ingenious and sedimentary rocks under El Morro are persistent and durable, allowing for construction of such massive stones and forts for them to stand for centuries. It was built for military defense, but the natural geology allowed it for a heavy structure to last over the centuries. I believe I did include a picture on this presentation of what it looked like a couple of years ago and what it looks like now. It has not really changed much at all. Builders did modify the natural cliff and produce a local stone to complete the fortification of El Morro and altered the space to kind of meet human needs. The neighboring areas were cleared and leveled out to allow defense access time and better visibility. Again, they just wanted to be able to see from all sides any attack that could come. Like I said before, the location of Puerto Rico is systematically active since both tectonic plates border the area. Old San Juan has been affected by earthquakes over the centuries, which have had minor structural stress on the fort. There is an added consideration of our geological risks in more modern times due to conservation efforts. But due to the geology of this site, El Morro has been protected from erosion and adverse events better than any parts of the island since it became a national monument. It was declared a UNESCO World Heritage Site and has ongoing preservation work involving geologic surveying and benefits from structural reinforcement to withstand potential quakes or sea-related erosion. So it is very well looked after. Now I'm going to get into one of my first topics. I chose a terrestrial biome. It is a tropical coastal grassland area, tropical dry forest edge. It is a narrow coastal zone where dry tropical grasslands meet urban modification. If you can kind of see, you can kind of see it on the very corner over here, kind of the grassy area. That whole area is a huge grass area where kids in Puerto Rico, like I have memories of my childhood just flying kites there. It's super windy because of the coastal areas and the saltiness and the winds, strong winds. So it just has tolerant plants and open grassy space. As you can see, there's not much um, plants, just kind of shrubs and grass. The limestone and volcanic rock promontory that El Morro is on has thin and porous soils, which limits de limiting dense forest movements. And over the centuries, grasses and low shrubs have been encouraged, ideal for building and maintaining open fields. That is the green lawn that you can kind of see in the very back. The elevation and proximity to the sea equals strong coastal wind and salt spray. Vegetation is limited to hardy plants that can withstand wind and rocky soils, coastal grass, sea grapes, and a few shrubs, like I mentioned before. You will see living on the biome iguanas, a lot of them. A bunch of seabirds are nesting around grasses, lesions gripped to the rocks, and lots of cats. We have a lot of stray cats in Old San Juan, and we have organizations that help feed them, and also locals help feed them too. I also included this picture just so you could kind of see the whole picture. This is El Morro, this is the whole area. You can kind of see the rock that I was talking about, the rocks that I was talking about earlier that kind of fortify it. Um, and you can see the tall walls. You can kind of see the garitas on there, but I mainly added this picture so you could see how large of a grassy area that is. People go there to fly kites, do picnics, and then on the very back, that's where kind of Old San Juan starts, like the actual city. For topic number two, I chose oceans and coastal systems, of course, because it's right next to the ocean. And Morro is a rocky coastal bluff that extends about 140 feet above sea level. It's considered a headland, which is formed when more resistant rocks, like volcanic or limestone layers, is eroded less than the land around it. For the erosional processes, the hydraulic action, which is the pressure caused by the waves slamming against a rock, abrasion, the water has particles that scrape against cliffs. It is salt water, salt weathering due to the sea spray, and then over the centuries, these processes have caused the edges of the cliff near Morro to slowly retreat. You can kind of see the rocks and the separation right there. With storm surges and sea level rise, due to climate change, the storm surges have created by hurricanes are much more powerful. So as a result, these storm surges have the potential to accelerate the coastal erosion and threaten the stability of the Morro foundation, alter sediment patterns around the islet. Um, it does have very high energy wave action because again, it's in the coastal area that erode as storm waves also move down the beach, down to the water towards the beach. Wave refractions. The rocks below El Morro are primarily limestone volcanic tuff, all former marine. Um, and yeah. So for the dynamic planet is my topic number three. I kind of included a map over here that kind of has the tectonic, the North Caribbean plates and then the North American plates. Puerto Rico straddles the boundary between the North American plate and the Caribbean plate. It is becoming compressed, twisted, and intruded upon by many complicated tectonic forces. And Morro and all of San Juan are riding on a microplate that is drifting east-southward about 2 centimeters a year, like I mentioned before. I do have a before and after. This was in 1901 and then in 2024. Kind of basically looks the same. Puerto Rico gets a lot of smaller earthquakes, especially along the northwestern coast, which usually go unnoticed. Earthquakes can create fractures in our bedrock underneath El Morro, cause micro movements in the limestone bed. It is settled on the loose bedrock, increase coastal erosion through fractures and a bunch of other things. For the volcanic past, the actual bedrock that El Morro is built on contains volcanic plastic rocks, like volcanic ash and debris lying beneath El Morro, laid down millions of years ago. While there's no current volcanic hazards on the island, Puerto Rico's geologic past has been shaped by volcanism associated with subduction zone formation. The foundations of El Morro consist of sedimentary and deposits at one time from marine sediments. Over time, these sediments have hardened into rock and uplifted tectonic processes currently being weathered. I'm sorry, I don't know why it's kind of cutting off half of my presentation, but this is the rock cycle acting out in the present. The wind, rain, salt spray, and wave erosion can erode the cliffs upon which Morro is built. These active and continuous processes are what makes it dynamic. Even the monumental stone fortress in Morro cannot escape them. And that is the end of my presentation. Thank you so much for listening.